In this video, we're going to look at part 2 of 7.5, which is solving radical inequalities. Now, we focused a lot with radical equations in part 1. We learned a couple of ideas, which was you can only take the square root of a positive number or 0. So this idea that inside the radical can only be either a positive number or it could also be the number 0. That is the key to even radical inequalities, is that idea. So this idea from the radical equations part is still important now, is inside the radical can only be a positive or 0, and it can only equal the positive number or 0 when you take the square root. That's going to be the starting point. That's the key to radical inequalities. Before we begin, we need to address that issue. So when we're solving, always check the domain first. Then go through the process for solving just like you would with an equation. And when you write your answer, you're going to need to look at the graph visually to see. So we're just going to kind of walk through an example, get some ideas first. So this one's kind of a basic structural setup. The radical is already by itself. There's nothing outside, no coefficients, no constants outside the radical. And I have my inequality. So square root of 4x plus 5 is less than or equal to 10. We're tempted to just start solving like we would an equation, but we shouldn't. When you're dealing with a radical inequality, you need to address this issue first. Inside the square root can only be a positive number or 0. So I have to look at this expression inside the radical first. And I'm going to take that expression and I'm going to set it to be greater than or equal to 0. So set the expression, the radical, to be greater than or equal to 0. That gives me 0 or a positive number. So I'm going to say 4x plus 5 is greater than or equal to 0. And then just solve it. So I get 4x is greater than or equal to negative 5. And you can leave it as a fraction. X is greater than or equal to negative 5/4. If you want to change it, since negative 5/4 is not a bad decimal, to negative 1.25, you can. Now, what does that mean? That's why this number line is below it, is to help us with the solving. Is if I plot that point using that inequality, x is greater than or equal to negative 5/4. Well, that would be a solid circle, because or equal to is included, and greater than would be going to the right. Now, what that means is when you're going through and solving, anything to the right of that number is going to be positive. So let me do it this way. So I'll draw kind of like a vertical line so we can separate. Anything to the right of that number is going to create a positive number. Anything to the left of that number is going to create a negative number when you plug it in. And I'll quickly verify that for you. Is here's negative 1.25. Let me just plug in negative 2. And we'll just see 4 times negative 2 is negative 8. Plus 5 is negative 3. And you cannot take the square root of a negative number, so that doesn't work. And you can keep going. I mean, I can pick negative 10 way out to the left. 4 times negative 10 is negative 40, plus 5 is negative 35, and you can't take the square root of negative 35. So we have to address this idea first, that the positive or 0 has to be in the square root. And that means anything to the left, I'm going to throw away. I cannot use anything over here. Any part of the solution that falls in that, I can't use. Any part of the solution that falls to the right is perfect, because I can plug it in and get a positive number. So let's try it out. Now that we have that domain restriction and we can check our answers on it, let's just solve. Well, the radical is all by itself, so I'm going to square the entire left side, and I'm going to square the entire right side. The square and square root cancel, and I get 4x plus 5 is less than or equal to 100. So I will subtract the 5. 4x is less than or equal to 95. And then when I divide by 4, I can leave it as 95/4 to be consistent with the other part. Or if you want to, you can change it into the decimal, which is x is less than or equal to 23.75, since that's not a bad decimal to use. But you don't want to box it or circle and say I'm done. you always have to compare it to that domain that we did in the beginning. So I have to take and I will make it into green. So I'm going to take this solution and I'm going to compare it to the domain that we actually looked at in this part. So less than or equal to 23.75. So here's 23.75. Less than or equal to is a solid circle going to the left. Now watch this. As I go to the left, I can still use all these numbers because they're positive when I plug them in. Positive when I plug them in. But what happens is when I hit this negative 5/4, I have to stop. I cannot cross that. Because if I cross that, I'm going to end up in this zone where I plug in and I get negative numbers, which is not allowed. So the answer, the solution space that I'm really using is between these two numbers. I'm not going to cross that boundary. So I'll just show the graph down here. It's between negative 1.25, negative 5/4 was a solid circle, and 23.75 was a solid circle. And we have to write that as an answer. That's the visual answer as the inequality on the graph. Now there's two ways to write this as an answer. I can write it as a compound inequality. My solution for x falls in between those two numbers. It was a less than or equal to. It is negative 1.25 is less than or equal to x, which is less than or equal to 23.75. That could be the way you write it as an inequality. If you want to use interval notation, you can as well. Since it's or equal to, it's a bracket, left to right, least to greatest, negative 1.25, comma, 23.75, it's or equal to, so you have a bracket. Those are the two ways you can write them on it. So if we take a look at that, we have to keep in mind this boundary. It will stop us if we're going to the left. Because as soon as I cross over, I'm going to get a negative number and I can't plug those in. So let's look at number 2, or the second example here. Same idea. You can be really tempted to start solving it, but you can't with a radical inequality. You need to check that inside, x minus 7. I have to make sure I create that boundary so I won't get a negative number if I plug everything in. Which isn't too bad in this case. X is greater than or equal to 7 when I solve. So visually what that means, greater than or equal to is a solid circle going to the right. Anything to the right. If I plug it in, I get a positive number, which is allowed. Anything to the left of 7, if I plug it in, I get a negative number, which is not allowed. I cannot cross over to that left side. This is the no-go zone. Anything I plug in less than 7 is going to give me a negative number in here, which does not work. So when I solve, I'm going to visually compare it to that and make sure we don't cross into that range. Now for solving, remember we have to get the radical by itself. So box, circle it, colored markers, pens, highlighter, whatever. So when I do that, I'm going to subtract the 4 first. And then I'm going to, still not by itself, I'm going to divide by 3 just like I would for an equation. And in this case, since it's thirds, I'm going to keep it as a fraction. To square both sides and square a fraction, I'm going to square the top of the fraction and square the bottom of the fraction, which is going to give me 4 squared is 16, 3 squared is 9. The square and square root cancel. X minus 7 is greater than 16/9. And now when I'm doing this one, I'm going to want to add 7 to both sides. So I get x is greater than 79/9. That is not a nice decimal, so we're going to leave that one alone as a fraction. Now, don't be tempted to do this and circle it and go, sweet, I'm done. Just like before, that's only part of the answer. We have to make sure we compare that answer to the domain we found here. So 79/9, just so you can see where to place it as a decimal, is approximately, and I say approximately, about 8 point, well it is 8.7 repeating. So it will be somewhere over here. Here's where 79/9 is. It is or equal to, sorry, it is not or equal to, it is just greater than, which means it is an open circle. And greater than would actually be going to the right. It's not even going towards this boundary restriction. It's pointing away from it. It is pointing to all these positive numbers over here already. There's no issues with it. I am not in any way going towards this bad area. I'm avoiding it completely by going to the right. So my answer is an open circle on it. So my answer is an open circle on 79/9 going to the right. So that is x is greater than 79/9. Notice there is no boundary on that one. There's no number on the left side like there was up here. And the reason why is our inequality in our solution is pointing away from that boundary already for us. We are avoiding it by going the other direction, so we don't have to keep it in mind. However, in this one, that 4x plus 5 example, it was less than, so I went to the left. And so as I go to the left, I am approaching that boundary, and I'm bound to cross into that zone I cannot cross. So that negative 5/4 stops us from doing that. So that's an interesting idea, is the less thans are pointing towards the left side of a number line where your negative numbers are. And you can't have a negative number inside the square root. So we have to create a stopping point with that boundary. However, the greater thans point to the right side, which are all positive numbers. And we are okay with positive numbers inside the square root. So maybe that's a way we can use to help us understand some of these things as well, is which direction are we pointing? Are we pointing towards the boundary? Because if we are, we're going to use it. If we're pointing away from the boundary, we're not going to use it. So let's try 2 more examples. Before I'm tempted to solve and just go through and square both sides, I'm going to take that 6x minus 5, and I am going to first figure out what works. So I'm going to take that expression, and I am going to set it to be greater than or equal to 0. A positive number is 0, so I'm going to add 5, and I'm going to divide by 6. 6 are not nice decimals on it, so I'm going to leave it as a fraction, and I'm going to visually see it so I can get my answer. So here is 5/6. Notice your domains are always or equal to, because 0 is allowed. So that is a solid circle, and it goes to the right. Again, what does that mean? I'll draw the boundary again so I can kind of see it. Anything to the right is allowed. It is a positive number. If I plug them in, I'm going to get a positive in the square root. I like it. Anything to the left, if I plug it in, is a negative number. I don't like it because I cannot put a negative number inside the square root. So I want to avoid this area completely. So now that I know that, I am going to solve. And when I solve, I want to make sure the radical is completely isolated by itself, which it is. So I square the left side and I square the right side. And I get 6x minus 5 is greater than 4 squared, which is 16. 6x is greater than 21. Now I have x is greater than 21/6. Don't be that student who does not simplify their fractions. Both those numbers are divisible by 3, and I get 7/2. That's not bad. That is even a nice decimal if you want to use it. X is greater than 3.5. Do not be tempted to circle that answer. We want to visually compare it to our number line with our domain. So greater than 3.5, so here's 3.5. Greater than would be an open circle, and it'd be going to the right. The question is, if this is our solution space right over here, am I even worried at all about my negative zone, about over in this area? And no, I'm not. My solutions are pointing away from it already. It's going to all those positive numbers. I do not care for it. I don't need this area at all. This boundary is not needed, so I can say x is greater than 3.5 and be done with it, because my solution is pointing away from that negative zone, so I don't need to worry about the boundary there. So let's look at number 2. before I'm tempted to solve it, before I'm tempted to begin, I better look at this 2x minus 5, and I need to find what values work. So 2x minus 5 greater than or equal to 0. 2x is greater than or equal to 5. X is greater than or equal to 5 halves. If you like the fraction like I do, use the fraction. Since halves are not bad as a decimal, I can say 2.5. Let's look at that visually. So greater than or equal to, again, notice your domain is always or equal to because 0 is allowed. So I have a solid circle at 2.5. And greater than or equal to be going to the right. I'm just going to go that far. I'm not going to go any further for it. And remember, what that does is it allows us to say there are two zones. There is the good zone where I plug in anything to the right of 2.5, I'm going to get a positive number. There is the bad zone where I plug in anything to the left of 2.5 and I'm going to get a negative number. So I don't like this zone. I can't have a negative inside the square root. I want to keep everything away from that zone. Now that I know that, I'm going to work on my solving. So in this case, when I'm solving, I want to get the radical by itself. So I am going to subtract that 2 over here. So I'm going to move that 2 to the other side. So square root of 2x minus 5 is less than or equal to 3. I'm then going to square both sides now that the radical is by itself. 3 squared is 9. The square and the square root cancel each other out. So I get 2x minus 5 is less than or equal to 9. We add the 5. I divide by 2. And I am not tempted to do that because I still have to take my x is less than or equal to 7. And I need to compare it to what we did up here. So less than or equal to 7. Here's 7. Less than or equal to is a solid circle. And I'm going to the left. And that has red flags going off right now. Is because if I'm going to the left, I'm going to the left, I'm going to the left, I am approaching this no-go side. I cannot enter that area. So I have to stop at that 2.5. So really, it looks like this. My answer is between 2.5 and 7. So I can write it like a compound inequality. 2.5 less than or equal to x, which is less than or equal to 7. Or I can write it as an interval. 2.5 with a bracket because it's a solid circle to 7, least to greatest, with a bracket. So hopefully these examples make sense. I try to really focus on you have to do this step first. And also help you see that if your solution is pointing away from that boundary, we don't need to worry about it. But if your solution is pointing towards that boundary, then that boundary needs to stop it from going any further. That is radical inequalities. If you have any questions,